Today our topic is how to compare the size of two infinite sets. Because everyone can compare two finite sets because it's very easy. For example, we have two finite sets A and B. Then how to calculate the size of these two sets? Because they are finite, so we can count how many elements in A. Say the number of A, and then minus the cardinality of B, and then we get a finite number, say A. If A is positive, we say A have a larger size than B, and vice versa. So we need some definition for the size or the cardinality of the infinite set. So define two infinite sets has the same if there is a correspondence between them. First, I want to say this definition makes sense because assume there is a room and there are many chairs and many people. We want to know the number of people. We want to compare the number of people and the number of chairs. So the first way is just we have introduced before that we can count there are how many chairs and how many people and find which number is larger. And the second way is to ask everyone to take seats on a chair and find if there are someone still standing, we say we have more chairs. So we may assume that set A is the people set and B is the chair set, and ask everyone to take seats. We can find if they are equal. So after this definition gives us the first proposition. The cardinality of natural number is equal to the cardinality of rational number in 0, 1. So how can we do that? We just need to find the 1-to-1 correspondence. That is, we say in natural number, we say it's just 1, 2, 3, 4, and in rational number intersect with 0, 1. We say the first element is 0, and the second element is 1, and what's the third? How about the third one? We know that every rational number can be written as a fraction, say Q over P. So we want to have an order of this thing. That is, we may want to let the denominator increasing. And so the third number is 1 over 2, and then 1 over 3, and 2 over 3, and 4 over 1. And what's the following one? It should be 2 over 4. We don't need that because it has appeared and here. So the following one is 3 over 4, and following this, we can find this sequence contains all rational number in 0, 1, and we find the correspondence between n and q intersect with 0, 1. And this shows this proves our proposition: the number of natural number is equal to the number of rational number intersect with 0, 1. So we want to know question which set is larger, natural number or real number in 0, 1. Is that equal? One may say no, because I cannot find that correspondence. But we cannot prove a mathematical question like this because you cannot find the correspondence, maybe someone can. So prove if someone finds a correspondence from n to 0, 1. Say R1 is equal to point A1, A2, A11, A12, and A13, and R2 equals point A21, A22, A23, and follow this step. We want to find x that is not equal to any Rn. So we may say x equal to point x1, x2, x3, and I want to construct x to be let xi not equal to aii. So I claim x is not equal to any number of Rn. Claim x is not equal to Rn. Because if x equal to some Rn, equals some Rn, we have xn equal to Rnn. That contradicts our assumption xi is not equal to aii. So we prove this claim. So we find the number in 0, 1 and not equal to any of Rn. So we prove this, they are not equal.